Okay, let's continue our discussion on microwave components. So, as you remember, we have started uh, first component microwave system, which is directional coupler. As we have discussed last week, uh, directional coupler is a device which is used in so many applications, but generally you can say it is used either to combine or divide signal. As we have discussed last week also, we have seen directional coupler is 4-port device. It has 4 ports. So as you can see here, this is typical directional coupler with 4 ports. One port here, port number 1. We call this input port. It's called what? Input port. Then there is another port here, which is our port number 2, and we call it a direct port. It's called what? Direct port. So as you can see here, when you apply signal at port 1, which is our input port, signal travels through this transmission line directly. You see this transmission line? This microstrip transmission line connects port 1 and port 2. So the signal travels from port 1 to port 2 directly through this transmission line. That's why we call this port direct port. When you open a directional coupler, there are 2 transmission lines, one here directly, another one is here. Okay, so these 2 transmission lines, as you can see from the diagram, they are very close to each other. So what will happen when you apply a signal at input port or microwave signal at input port number 1? Let's say we apply power P1. Signal with power P1 applied to input port. So what will happen? Signal will start to transmit directly from port 1. This is our port 1. It starts to transmit to this through this transmission line to port 2, right? But because of this very close transmission line 2, this is another transmission line. As you can see, they are very close to each other. There is coupling, induction. Some signal power transferred or sampled from transmission line 1 to transmission line 2. Small portion of the signal is coupled or sampled or transferred from transmission line 1 to transmission line 2. So let's say if you apply power P1 here, let's say 10 watt signal power at port 1, we connect here our coaxial cable. So signal start to transmit directly from port 1 to port 2, right? That is direct port. But because of this coupling, a small part of the signal is transferred from transmission line 1 to transmission line 2. Okay, this is transmission line 1. This is TX2. So signal coupled, small portion of the signal coupled from transmission line 1 to transmission line 2. Here you see there is no physical contact between the 2 lines, but they are very close to each other. So when a signal transfer in one line, it will be coupled, just like a transformer, as we have said last time. If you have a transformer with primary winding, with a transformer with primary winding here, if there is another winding very close to the first primary winding, no contact between the two windings, if you apply a primary current here, what will happen? You will get a current here without any physical contact. The current, the signal is, the voltage or current is induced by magnetic coupling, right? We call it magnetic coupling. So you will get a current, secondary current here without no contact. Energy transfer from one winding to another winding by coupling, magnetic coupling, if they are very close to each other. Same thing happen here. So if you apply a signal at port 1, P1, we call P1 what? Input port. Signal transmit directly to port 2, direct port. But because of coupling, you will get small amount of power in this port. We have another port here. We call it port 3. What type of port 3 is called? Coupled port. Okay, it's called coupled. It's called coupled port. Okay, so let's say if you apply 10-watt signal as input, 9-watt may be transmitted directly. What happened to the remaining 1 watt? How much power remaining? The remaining watt will be 1, right? So this 1 watt power, the remaining 1 watt power, maybe 0.5, 0.25, just as an example, watt will be lost. Lost as attenuation, right? Any device has some insertion loss. What we call it what? Insertion. It's called insertion loss, right? Any device absorbs some amount of energy from our signal. We call it insertion loss. Okay, so how much power we lose due to insertion loss? 0.25 watt. How much remaining? 0.75 watt. This amount of power is what we call it coupled. It's called what? It's called coupled. So you see here, we apply 10 watt. 9 watt is transmitted directly through transmission line 1. The remaining 1 watt, 0.25 may be lost as attenuation. 0.75 watt, we get it where? Coupled port, P3. So P3 0.75 watt. So you see, signal divided into 2. Signal comes here, and it's here at this point is divided into 2. One directly, another one goes to port 3 here, which we call it coupled port. It's called coupled port. So when you see these directional couplers, you will see here this directional coupler, as you can see, it's directional coupler used from 1 up to 20 gigahertz application. So this is port 1, input port. This is port 2, direct port. There is another port here. What is this port? P3, we call it the coupled port. It's called what? Coupled port. So a signal transmits directly from port 1 to port 2 through this device, but small part of the signal also goes to port 3 by coupling. So the input signal is divided into divided into two parts. Direct transmission, coupled. Small signal, not too much, small part of signal coupled to another port, what we call it coupled port, P3. So you can see here, this is different type of coupler. Again, how many ports? Port 1, port 2, direct port 3, coupled port, and port 4, isolated port. I will come to this isolated port. But now you know port 1 is input, right? Input port. Port 2 is what we call it direct port, right? Direct port. Port 3, we call it coupled port. So when you apply signal, small part of signal will transmit directly, small part of signal will go to port number 3. We call it coupled port. Okay, so this directional couplers, very important device in microwave. I will explain applications later. Now, you know why we call this device coupler. Why it is called coupler? Because when you apply a signal here at input port 1, signal divided into two. One goes to port 2 directly, another transferred to transmission line. We call it coupled line here. There are two type of lines here. The first transmission line, this one, is our main line. So a signal transmitted here will go directly to port 2, direct port. But there is another transmission line here, which is called coupled line. So if you apply a signal here, small power will go to this line. So small part of the signal comes to port number 3. We call it coupled port. Signal transfer from one line to another line by coupling. That's why it's called. This device is called a coupler. But another thing, very important thing, you know, is directional. These couplers are directional. So what does it mean by directional? So here, when you apply signal from this side, this is now our input, right? P1, input line. So here we have our first transmission line, direct transmission line, the main transmission line. As you can see here, it is our main line. Is this one? So signal transmits here directly from port 1 to port 2, this direction, right? So because of this second transmission line, as I said, there is coupling, signal transfer, sampled from one line to second line. So after coupling, there are two options. The signal will go this direction. Okay. If this signal goes this direction, you will get it at this port. If a signal moves in this direction, it will go to this port. So we have two ports, port 3 and port 4. So because this device is directional coupler, if input signal comes here, it transmitted directly here through transmission line 1, then the coupled signal only goes to in one direction. Which port? It will come to this port only, port 3. We call it coupled port. Okay. So this is wrong direction. If the coupled signal comes in this direction, it is wrong. It is wrong. Okay. So the coupled signal must be go to the coupled port. But there is no perfect device. There is small amount of signal, coupled signal, transferred signal transmitted in the wrong direction to port number 4, which is called isolated port. Okay. So you see here, You see here, this directional coupler, you can apply your input here. You will get your direct transmission here. Signal will be transmitted in this direction directly. Okay. So because there is another line very near to this signal is divided into two. So one small part will go to port number 3. This is what? P3, coupled port. So you see the signal P1 divided into P2 and P3. What is this signal? P3. What is this signal? Direct P2. What is the input? P1. Okay, P1 divided into 2 by this coupler. But there is another port here. We call it isolated port. As you can see here, we put some device. I call it terminator. It's called terminator. Terminated here. We don't need. We are not using this port because this device is directional. The sampled signal only go to port number 3, not port number 4. This is P4, which we call it port isolated port. Now, if you ask me why we need this isolated port, it depends on the application. If a signal, in directional coupler, you can apply a signal from this direction. If you apply a signal from this direction, this will be input port. This will be output port, right? Where is the coupled signal? Here. Only very small amount will go to the wrong direction. This is wrong direction. We don't need coupling at P4. What we need P4? P4 must be 0. No coupling in this direction. Because the device is not perfect, you will get some P4s, very small P4. We'll discuss that one. But this is what you call it P3. In some applications, you can apply your input from this direction. Now this is input port. This becomes what? Direct port. You can apply in both directions your input. In this case, this will be our coupled port. You see, previously this was isolated port. Now because signal comes in opposite direction, this becomes our coupled port P3. This one becomes isolated port. We don't need P4 now. All the signal after you transmit through this wire, when it reaches here, it's divided into 2. One will go to directly, another will go to coupled port. No coupling here. In this case, there must be no coupling, right? Look here, when this is input, so this is our first cable, it transmitted here. When it reaches here, there is no coupling. P4 must be how much? Must be 0. No division of signal. Signal continues to transmit, but when it reaches here, now it's divided into 2. One will go to coupling port, one will go to the direct port. Small amount will come here, P3. That is coupled port. This is direct port. When you apply the signal in the reverse direction, this becomes input port. So signal comes here. Now there is no division here. Signal will not divide here. But when it reaches here, it's divided into 2 parts. One part will transmit directly, another part will come to this one. So depends on the direction. One of these 2 ports can be isolated port or coupled port. That's why we have 2 ports. So always keep in your mind, when you see directional coupler, it is a 4-port device. One port is input with power P1. Another port is direct port with power P2, but the signal is divided into 2. So we have coupled port P3. Okay. That's a directional coupler. We'll discuss applications, but before that, let's see some figure of merits, specifications of a directional coupler. When you buy a directional coupler, when you use a directional coupler, you have to know these 4 specifications or figure of merits. So let's discuss one by one. So what is the first specification of directional coupler? It's called coupling. When you buy directional coupler, you will see this coupler at some point. You will see how much is C. It can be 10 dB coupler. Okay, it can be 10 dB coupler. This coupler can be 20 dB coupler. So C, coupling, what does it mean? The first specification of a coupler is coupling C. So what does it mean by C? So that's the first specification we have to know, coupling. Coupling specifies how much input power is sampled. Why we need directional coupler? To take some sample from the main transmission, right, by coupling, to divide a signal into 2 parts. So how much power is sampled? How much power is coupled from main transmission line to coupled line? From P1 to P3, how much power is coupled? Is depends on C, coupling specification of a directional coupler. So when you see this example, we'll see this one, example number 1. We have a directional coupler with coupling C. So C is given. When you buy any coupler, you have to know how much C is. So it represents what? How much the coupler is given? 10 dB. Okay, 10 dB. That is the specification of this given coupler. C is 10 dB. So what does it mean by C? As we have discussed, C is equal to how much power is go to port 3 when you apply signal at port 1. So here, when you apply a signal at port 1, input port, it's divided into 2, right? Some part will transmit directly. Some part will go to port 3, coupled port. This port is called direct port. This port is called coupled port. So how much power is transmitted or coupled or sampled from the main line to the coupled line? That is what we call it C. Okay. So in this example, how much is C? 10 dB. Our coupler is 10 dB directional coupler. C is 10. So here, how much is input power? P1 is equal to 10 milliwatt. Input power, we apply here a signal with 10 milliwatt power as input. Okay, that's given. Now we are asked, assume this coupler has no insertion loss, no attenuation. So assume it is lossless. Okay. So we are asked how much power is P2. Okay. How much power goes to port 3? How much power goes to port 4? You see, this directional coupler is used to divide a signal, right? So input power at 10 milliwatts given. At port 1, we apply 10 milliwatt signal as input. So the question is, what are the power outputs at port 3, port 4, and port 2? How much power? So let's see coupling formula. What is C? From here, C is equal to 10 logarithm of of what? 10 log of P1, the input power, divided by P3. How much power is coupled? Okay, that is our formula. C, what we call it coupling, is equal to 10 logarithm of P1 input power divided by P3. What is P3? How much power is sampled, how much power is coupled into port 3. So let's see. C is how much? This coupler is C 10 dB. C is given. 10 dB coupler is equal to 10 logarithm of, okay, how much is P1? P1 is 10 milliwatt. Here we apply 10 milliwatt input power, it's milliwatt, divided by P3. So you see here how much C determines how much P3. How C of a coupler, coupling of what is the first specification? Is coupling, right? So what is coupling means? Coupling determines, C determines how much power goes to port 3 from P1. So if you know C, in this case 10 dB, you can calculate what? You can calculate P3. So how you calculate? Divide both sides by 10. Okay, divide both sides by 10 to cancel this. Now 10 divided by 10 will be 1, which is equal to log of, now 10 get cancelled. So 10 milliwatt 10 milliwatt divided by P3. Okay. Because 10 get cancelled. I need to cancel this 10, so divide both sides by 10. 10 by 10 will be 1. 10 by 10 cancelled. Now, this is logarithm base 10. So what we have to do? To cancel the log, we have to use 10 divided 10 to the power of 1. So 10 to the power of 1 is equal to, now the log cancels, so it will be 10 milliwatt divided by P3. Okay, so here what will be P3? How much power goes to port 3, coupled port? 10 divided by 10, right? This is 10 to the power of 1 is 10. This is 10, so 10 milliwatt divided by 10. So how much? It will be 1 milliwatt. So if you apply 10 milliwatt input power at port 1, how much power goes to port 3? Only 1 milliwatt. Only 1 milliwatt goes to port number 3, coupled, okay, transferred, sampled from the main line to the coupled line. So C is very important specification or figure of merit for a coupler. What is C? C indicates how much power sampled or transferred from first transmission line to the coupled transmission line. Because as we have discussed, directional coupler is used to sample, to divide a signal into two. By coupling, the two wires are not contact physically, but they are very close to each other. So when you apply signal here, it will be coupled by magnetic coupling or induction from one line to another line. So how much power is induced? How much power is sampled or transferred from our main line to the coupled line is determined by the value of C. Okay, so when you use a coupler, first thing you have to check is how much C can be 10 dB, it can be 20 dB. So C is very important. Now in this case, if this coupler has C 20, what will happen? If you use another coupler with coupling 20 dB, what will happen? Let's see. Input power is again the same, 10 milliwatts, right? Now, this directional coupler we use, instead of 10, we are using a coupler with 20 dB. When previously, when we see when C is 10 dB, how much is P3? How much power sampled? Sorry, it's P3. P3 is how much? 1 milliwatt. Okay, 1 milliwatt. From 10, 1 milliwatt goes to port 3 when C is equal to 10. Now let's bring another coupler with 20 dB coupling. C now is 20. Now how much P3 will be? How much power this coupler will sample? So what is the formula for C? C is equal to 10 logarithm of input power P1 divided by P3. Okay. So how much is C now? C is now 20, which is equal to 10 log of P1, which is how much? 10 milliwatt. That is the input power divided by P3, which is coupled power. Now divide both sides by 10 to cancel this 10. So divide both by 10. So this will be how much? 20 divided by 10 will be 2. This will be logarithm of P1 divided by P3. We know P1, 10 milliwatt. We don't know P3. Okay, so what is this logarithm? Base 10. So 10 the power of 2, right? Is 10 the power of 2 is equal to this part. The logarithm will be removed. So 10 milliwatt, that's our input, divided by P3. So how much is P3? This case, for this coupler, P3 will be this 10 milliwatt input divided by what is 10 to the power of 2? It will be 100, right? 10 to the power of 2 is 100. So how much is this? 0.1 milliwatt. Look here. When C is 10 dB, how much power sampled? How much power goes to port 3? 1 milliwatt. When you use a coupler with C 20 dB, okay, how much this coupler sampled how much power? P3 will be only 0.1. Very small amount of power is sampled. So what do you understand from here? As C increases, sampled power decreases. Okay, P3 sampled power or coupled power decreases. Directional coupler with C10 dB samples 1 milliwatt from what? From input 10 milliwatt. Here we get 1 milliwatt, right? For how much? Coupler with C10 dB. Coupler we see 20 dB, it samples only 0.1 milliwatt. The remaining will go direct. The rest, 9.9 milliwatt will transmit directly. Only 0.1 signal is coupled or transferred or sampled to the coupled port. That is what we call C. Okay, so we have seen what? We have seen the first figure of merit or specification. Specification means what? When you buy any device, it has properties, right? So when you can check this, go to online markets and try to search directional couplers. You will find different directional couplers. Each directional coupler has some C value, C, coupling value. So what does it mean by C? C, how much power, C determines what? How much power goes to coupled port. How much power is sampled. How much power is coupled from the main line to the coupled line. That is what we call it coupling. Okay. The second specification, we call it insertion loss. As you can see here, it is insertion loss. So what does it mean? Any device, okay, any passive device, if you transmit a signal through this device, the device absorbs some amount of energy. There is always insertion loss. What we call it what? Attenuation or insertion loss due to components. Okay. So when you use a directional coupler, some amount of energy is absorbed by the coupler. We call it insertion loss. So how much signal is lost during this, when you transfer a signal through a coupler, how much power is absorbed or lost by the coupler? We call it insertion loss. You know what that means by insertion loss. As we have discussed before, in microwave systems, there are two main sources of signal power loss. What is the first one? Insertion loss, right? Loss due to components, attenuation. What is second one? Return loss. Loss due to impedance mismatch. If two devices with different impedance, signal will be reflected back, right? That's a return loss. Another loss is insertion loss, loss due to the components. Okay. Two more specifications here. Very important one, isolation and directivity. As we have discussed, directional coupler, it is directional. When you apply P1, some amount of power is transmitted directly here. There is also a signal which comes to this coupling, right? Second transmission line. This all signal, as we have seen here, if you apply a signal here, this directional coupler, this is our coupled port, P3. This is P4, isolated port. This is what? P2. So signal will transmit directly. It should not go to P4. P4 is isolated port. Signal will be divided only at port 3 and 2. One will go direction, one will go this direction. Okay. How much signal will come to P3? Determined by what? Determined by C. But because of design imperfection, there is coupling which goes in the wrong direction. We don't need P4. P4 must be 0. This signal only divided into 2 to P2 and P3. But there is a small amount of power coupled in the wrong direction. How much is that? Is determined by these two properties, what we call isolation and directivity. So let's see the example. So what is isolation means? So before that, when you say insertion loss, always the output power is less than the input power. in directional coupler, always if you apply some input power here, output power P2, always P2 is less than P1. Why? Why the P2 is less than P1? Because of two reasons. One, some part of signal goes to P3, definitely. Signal divided. Another reason, there is attenuation by this component. We call it insertion loss. Okay, because of these two reasons, always the output power is less than the input power because of two reasons. What is the first reason? Some of the input power is coupled into the coupling port, and it does not reach output. Second reason, some part of power is absorbed inside the directional coupler. We call it insertions. Okay. Now, when you come to isolation, here, directional coupler supposed to sample power only in one direction. That's why it's called directional. The name of this coupler is directional coupler. Why we call it directional? Because the sample power must move or transmit only in one direction, P3, no P4. But no coupler is perfect. Okay, we cannot design a 100% perfect device. So what will happen? The small amount of power goes in the wrong direction. Okay, so this amount of power go wrong direction sampling, we call it isolation. We call it what? Isolation. Let's see this by example. So what is isolation means? Isolation I means tail log of P1 divided by P4. How about C? Coupling. This is coupling in the correct direction, which compares what? Tail log of input power P1 compared with P3, right? But isolation compare P1 with P4. What is P4? Wrong direction coupling. Okay, it is wrong direction. We don't need signal at port 4. Okay, port 4 is used only if the signal comes in another direction. Okay, if signal comes from this direction, only port 3 is used. If signal comes from this direction, only port 4 is used. Port 3 will be isolated. If signal applied from this direction, port 3 is used. Port 4 will be isolated. Okay, so theoretically, coupling. So when you see a directional coupler, when you apply signal from this direction, signal will be divided into two. One will go to port 3, one will go to port 2, right? How about port 4? Is isolated. As you see, it's closed. We don't need you. We are not using it. We are only using what? The coupled port. Now, if a signal is applied from this direction, this port will not be used. We use what? We use this port. So signal will come here, some part will go here, some part will transmit. So it's divided into two. But in this case, must be isolated. Okay, it must be zero power to this port. Zero power. That's what we call it the directional coupling. But practically, there is small amount of power go in the wrong coupling direction. What we call it isolation or directivity. The two factors here. Both isolation and directivity determines how much power is go in the isolated direction, this direction. As you say, the signal transmits here. When it reaches here, it's divided into two. One will go to the coupled port, another continues directly, right? Now, with this signal, coupled signal, always must be go in only one direction. If it goes to the wrong direction, we call it isolated or directivity. So let me explain this using example.